Okay, so here we're looking at our first example of rectilinear motion. We have an object moving along the x-axis, and its velocity is given by cos of pi over 2t, and our velocity function is going to be in centimeters per second. So fine. We are going to be assuming here that if it's moving along the x-axis, positive velocity means that it's going to be moving towards the right, and negative velocity would mean that it's going to be moving towards the left. So here, let's take a look at part A. Find its displacement over the time interval from 0 to 3, and in part B, we're going to be looking at the distance instead of displacement. Okay. So the displacement from 0 to 3, we're going to have to use our formula we saw in the last section, and that's going to be the integral from t1 to t2, and we are integrating here our velocity function. So we can plug it in. We know that we're starting off with time t equal to 0, we're going until time t equal to 3, and our velocity function is cos of pi over 2t. So we're integrating cos of pi over 2 times t, and now we're just going to use FDC2 on this, and so we need to find our antiderivative of cos of pi over 2t, which is going to be sine of pi over 2 times t, and we're going to take this pi over 2 and we're going to divide by pi over 2, which is the same as multiplying by 2 over pi. Now we want to finish off with FDC2. We're going to evaluate this from 0 to 3, and this should be fine. We have just 2 over pi multiplied by sine of 3 pi over 2 minus sine of 0, and we know here sine of 0 is 0, sine of 3 pi over 2, this is going to be equal to minus 1. So if we put everything together, we get 2 over pi multiplied by minus 1. We get negative 2 over pi. And for us, our units were centimeters per second for velocity. So this displacement is going to be negative 2 over pi centimeters. Now, let's take a look at part B. So for part B, we're looking to find here the distance. Okay. Now for distance, we're going to use a slightly different integral. We're going to be looking at the integral from t1 to t2, not of velocity, but instead of the absolute value of velocity. Okay. Now we know that we should be thinking of the absolute value as a piecewise function. Okay, so really we end up with velocity absolute value being equal to either just itself if it's already positive, or it's going to be negative itself if it was negative. Okay, now for us, our velocity function is going to be cos of pi over 2t. So really, we are very much interested in knowing when our cos of pi over 2t function is going to be positive and when it's going to be negative. Okay. So really, if you want to know when it's going to be positive and when it's going to be negative on the interval from 0 to 3, then we're going to be very much interested in knowing when it's 0. So here we're going to solve velocity equal to 0. Okay, so for us that's going to be when is cos of pi over 2t equal to 0, and if you think about the cos function from as t goes from 0 to 3, okay, that means 1 that t could be equal to, or let's back it up a second, that's going to happen when pi over 2t is equal to pi over 2, which means that t is going to be equal to 1 second. Okay, so at time t equal to 1 second, our velocity is equal to 0, and now we want to know, is it going to be going from positive to negative there, or from negative to positive? So we can set up here a little bit of a time interval chart, so we're going to be looking at the time from 0 to 1, and then from 1 on, okay, and from us, really, we're interested from knowing from 1 to 3. So we can plug in a test value into our cos function. If I plug in, let's say, t equal to 0.5 and our test value of t equal to 2, what's going to happen with our cos function? Well, let's see. If I plug in t equal to 0.5, then really we're looking at cos of pi over 4, and that's going to be a positive value. If I plug in t equal to positive 2, then we're looking at cos of pi, which is negative 1, and so that's going to be a negative value. So really, we know that our cos function goes from positive to negative at t equal to 1 second, and we could sort of summarize that here. We know that cos of pi over 2t is larger than 0 on the interval from 0 to 1. And it is going to be less than 0 on the interval from 1 to 3. Okay, and that's very much what we're going to use when we go to do our absolute value integral. So really, our distance, okay, our distance is the integral here of absolute value of our velocity. So we have integral from 0 to 3, absolute value of cos pi over 2 times t, and we could split that up. We know from 0 to 1, the cos function will be exactly equal to itself. So from 0 to 1, we're going to just evaluate the integral of velocity itself, just cos of pi over 2t. But from 1 to 3, we know that the function is going to be negative. And so we're going to be replacing it by, essentially, negative itself when we drop the absolute value. So from 1 to 3, we will be integrating not just cos of pi over 2t, but instead negative cos of pi over 2t. And so really what we end up doing is we have taken our distance, we've taken the absolute value of cos, we've split it up into two different integrals, one on an interval where the cos function was positive and one where it was negative. Okay, so now let's actually just evaluate these two. We end up getting in the first one, we have the same antiderivative, so it's going to be 2 over pi times sine pi over 2t. We evaluate that from 0 to 1. In the second one, we subtract it, so that's minus 2 over pi sine pi over 2 times t, and that one's from 1 to 3. So we finish off FTC2 for both of them. We have 2 over pi multiplied by sine of pi over 2 minus sine of 0 minus 2 over pi times sine 3 pi over 2 minus sine of pi over 2. So let's just figure out all these values involved. We have here sine of pi over 2. Okay, that's going to be equal to positive 1. We have sine of 0, that's going to be 0. Again, we have sine of pi over 2, that's going to be equal to 1. And sine of 3 pi over 2, that's going to be equal to minus 1. So let's plug everything in, make sure we're careful with all of the values. So we have 2 over pi multiplied by 1 minus 0 minus 2 over pi multiplied by minus 1 minus 1. So really we have 2 over pi, and this is going to be from here a double negative, okay, because we end up with minus 2 over pi multiplied by minus 2. So we're going to end up actually with 6 over pi for our distance. Now again, we're talking about centimeters, okay, and that's going to be our distance traveled, okay, from 0 to 3 seconds. It will travel 6 over pi centimeters. So one thing I really want to focus on for a second is we end up in our result for A we have displacement. Displacement for this one actually turned out to be negative. It was negative 2 over pi centimeters. And for B, we ended up with our distance. The integral of the absolute value of velocity was 6 over pi centimeters. Now, one thing is that this should come as no surprise. Okay, the distance is always going to be a positive value, even if the displacement was negative. Okay, the second thing is, what have we actually calculated for both of these? So let's just take a look actually at the graph involved for cos of pi over 2t. This is our graph from 0 to 3, and we essentially did the definite integral. We looked at the area underneath the curve, which is these two regions there, and we ended up getting a negative value. Well, yes, that makes sense because this region below the x-axis is essentially twice as large as this region above the x-axis, so we ended up with an overall displacement of negative 2 over pi centimeters. Now, let's take a look at the distance, okay, and the graph of the absolute value of cos of pi over 2t. So here we have absolute value of cos of pi over 2t, and we remember, based on our piecewise understanding of a absolute value function, that if the function was already positive, we don't change it, but if it was negative to begin with, then we're going to change the sign to make it positive. So what we have done then for cos of pi over 2t is, on the region where it was negative, we have taken it and made it into a positive function. So now when we integrate, what we're doing is we're taking this region, which is positive, and we're adding it to the area of this region, which is also positive, and we end up getting an overall distance of 6 over pi centimeters. Okay, so you should always expect your distance to be positive. You should also always expect your distance to be larger than or equal to the displacement. Okay, so now that we have finished off this example, let's take a look at one more.